Okay, so today we're going to be reviewing our 3.3 units, going over the square roots, cube roots, number sets, all that kind of stuff. Okay, so one thing you are going to need for this unit is a calculator, and it needs to be a calculator that is capable of doing square roots and cube roots. So hopefully you guys have that. And this unit shouldn't be too tough because, again, it's just using your calculator. So let's go through this. So number one wants me to find the cube root of negative 64. So in our calculator, I'm going to go over the important buttons. So for the calculator here in class, we have the TI 36X Pro. To do a cube root, you need to do this multi-root button. It's the second option of your exponent button on your calculator. So to use the multi-root, you have to start by identifying which root you're finding, which is the cube root or the third root. So you type in a 3. Then you do second and the multi-root. Notice how it goes on the shelf. That means it's a cube root. And then we put in negative 64. And again, this is basically just finding the root of a number that has been cubed, or basically what number did I times by itself 3 times that gave me negative 64. And when I do that, I get negative 4. So the cube root of negative 64 is just negative 4. That's it. That's my only root. Okay. Then number 2 here is a square root. If there's nothing on the shelf here, it's just a normal square root. You could do 2 and then the multi-root, or there is a square root button. It's a second option of the squared option. So you'd push second, square root, and then we want to do negative 16. Okay, when we put that in our calculator, we get an error. Okay, the reason for that is we are finding the root of a number, or whatever number I multiplied by itself that gave me negative 16. But if I think about that, there isn't a number you can multiply by itself that would equal negative 16, right? Because if you do 2 times 2, it's 4, right? If it's negative 2 times negative 2, it would also be 4. So no matter what, when you multiply a number by itself, it's always going to be positive, because it's either a positive times a positive or a negative times a negative, which is also positive. So if you have a square root of a negative number, there is no solution. So no solution. Okay, just not possible. I'm going to box these in because these are my answers. Okay, number 3 is a cube root. So cube root. So 3 cube root of 1,331, which gives me 11. So the cube root is 11. Not too tough, right? Like you can see, it's just using your calculator. Number 4 is the square root of 81, so you do the square root, 81, and that's 9. Now, here's the thing. I kind of talked about it up here, but with square roots in particular, there are actually 2 different roots that it could be. Because you'll notice this 4 had 2 different numbers that when multiplied by itself equaled 4. It could have been 2 or it could have been negative 2. Your calculator will always give you the positive root. But with square roots, there are 2 possible roots. There is a positive and a negative possibility. So it says the square root of 81 is 9, but it's actually positive or negative 9. So you could write it like that, or how I prefer to write it would be 9 or negative 9. Both of those would be correct ways of writing it. Okay? On your Canvas stuff, you generally have to write it as this. Okay, we make you write it as 2 different numbers because it's important to understand that you get 2 different roots. Okay? When you have a square root in front of a square root, or a negative in front of a square root, sorry, it's just wanting the negative root. So like I just said, there's 2 roots. Well, if it's in front of the square root, it just wants the negative root. If it's inside the square root, it's no solution. But outside, it just wants the negative root. So the square root, in fact, I can put it in my calculator just like I see it, negative square root of 36, and the calculator will give me the negative root, which is negative 6. So it just wants that one answer there. Okay, cube root of 25. So cube root 25 is not a nice number. Okay, so what we're going to do, and we don't have written what we want, so I'm going to go off of what we did for the quizzes earlier, and I guess I'm going to do this on the test too. We're going to round to the nearest hundredth, or the second decimal spot. So it's 2.924, so that would round to just 2.92. Again, it's a cube root, so there's only one root, so I don't need to worry about the plus or minus. Okay, square root of 58, so second square root, 58, and it gives me the square root of 58. So when that happens, you need to turn it to a decimal. The decimal button is this one right here, right above the enter. You just hit that, and it converts it to a decimal. So again, I want the hundredth, so 7.615 would round to 62. So plus or minus 7.62. Okay, and then last one, square root of 196. Square root 196 is 14. So again, that is 14 or negative 14. Again, you can write it either way with the plus or minus, or it's two different numbers, but I'll leave that to you. Okay, now that we have figured out how to find square roots and cube roots, we're going to use that knowledge to solve some equations. So here we have some equations that are being, or some variables that are being squared or cubed. And again, in order to square root something, to get rid of a square, the opposite of a square is the square root. So if I want to get this n by itself to figure out what it is, I have to find its square root. But if I square root that side, then I have to square root the other side to maintain equality. Now, square root of n squared is n, but the square root of negative 30 is no solution, because you can't square root a negative number. So that is just no solution. Okay? The trick here with these equations is to get the variable by itself. So if there's anything next to the variable, you need to get it away, and then cube root or square root, depending on what the exponent is. Okay? V squared equals 80. So again, this is a square, so I'm going to square root each side. Square root of 80 is 8.944. So V could equal 8.94. Again, since I just square rooted, there are two roots. Or V could equal negative 8.94. Those are my two possible answers. Okay, the next one, we have a couple of numbers next to my squared variable, so I have to get rid of those first. This is just a two-step equation, right? We always get rid of this number that's adding or subtracting first, then we get rid of the number next to the variable. So we're going to get rid of this 7. It's adding, so we have to do the opposite to move it. So we'd minus 7 to each side. Gives me 7x squared is equal to 252. And then I divide by the 7. And 252 divided by 7 is 36. So that leaves me with x squared is equal to 36. And then I would square root, right? And the square root of 36 is 6 or negative 6. So x could equal 6 or x could equal negative 6. And that would be my answers. Okay? Again, not too tough. Then over here, we have the negative n squared is equal to negative 100. Again, I need that n to be all by itself before I can square root. So the very first thing I'm going to do is I'm going to get rid of that negative. This is like a negative 1 multiplying, so to get rid of it, I have to divide by negative 1 to each side. And that gives me n squared is equal to 100. Then I square root each side, and the square root of 100 is 10, so n could equal 10, or n could equal negative 10. Again, if it's square roots, there are two possible answers. Square roots have two roots. Okay, next one, we have m to the third power, or m cubed, over 3 equals 243. So I need to get rid of this 3. It's dividing, so to get rid of it, I have to multiply each side by 3. 3's cancel out. You're left with m cubed is equal to 243 times 3 is 729. Okay, then you would just cube root each side, and the cube root of 729 is 9. And with cube roots, remember there's only one root. So I only have to worry about whatever my calculator tells me. So m is equal to 9 would be the only answer that would work. Okay? With these others, if I used 6 or negative 6, I'd get the same answer. If I plugged in negative 6, I'd still get 259 is equal to 259. If I plug in 6, I'd still get 259 is equal to 259. It doesn't matter. But here I can only plug in 9. Because if I plugged in negative 9, I would not get 243. Okay? Over here, there's nothing next to this t cubed, so I'm just going to cube root to start. So the cube root of negative 3,375 is negative 15. So t could equal negative 15. That's all you had to do. Not too tough, right? These are pretty easy. Calculator does all the work for you. Okay, a couple more problems, and then we'll get to the different sections here. Sorry, it's going to be a little bit of a longer video, but I am going over the entire review with you guys, which means I'm going over what the entire test will look like tomorrow. So if you're struggling at all with any of these things, watch the entire review, because I am doing everything, and this is basically a version of the test. So number 15. We need to get the t cubed by itself, so I got to get rid of this plus 111, so I'm going to minus 111 from each side. It's going to give me t cubed is equal to negative 343, and then I would cube root. Again, get the variable by itself, then cube root. Cube root's the last thing you do. Cube root negative 343. And I get negative 7. Again, cube roots only have the one root, so negative 7 is my only answer. Okay, and then this last problem, negative 6w to the third plus 10. Again, two-step equation. I want to get rid of the 10 first because it's adding and subtracting, then I'd get rid of the negative 6. So it's plus 10, so I'd have to minus 10 to each side. Gives me negative 6w to the third is equal to negative 750, and then divide by negative 6, and negative 750 divided by negative 6 is positive 125. So w to the third power, or w cubed, equals 125, and then the last step would be to cube root each side. So cube root 125, and I get 5. So w is equal to 5. Not too tough, right? Okay, that's how you solve equations with exponents. Involves finding the root, right? You get the variable by itself, and then you find the corresponding root depending on what the power is. If it's the third power, then you cube root. If it's the second power, then you square root. Okay? Then this next section, all we're doing in this section is ordering these numbers from least to greatest. Now, these numbers are expressed in various forms: fractions, cube roots, whole numbers, decimals. So really, in order to compare these numbers, we have to be able to get them to the same format. Easiest format to get them to is decimals, so that's what we're going to do. So if it's a fraction, you just do the top number divided by the bottom number. So negative 2 divided by 3 is negative 0.6 repeating. So this is negative 0.6 repeating. Okay? And then the cube root of 12 is 2.28. And you can round this to the 100th or the... Oh, lights went out. There we go. I know my video's getting long if the light goes out. Sorry, guys. Okay. 2.89. I'm just going to round it to 2.929. So 2.29. Okay. 2.5 repeating is already in a decimal form. -3 is already in a decimal form. And then 11 over 5. 11 divided by 5 is 2.2. Okay. Then I'm going to organize these from least to greatest. So again, if I'm on a number line, what would be the leftmost number? Well, it would be the most negative number, right? So D would be my least number. -3 would be the least number. Then I only have one other negative, so -0.6. So that would be A, would be the next least number. Then I have a bunch of decimals here, right? I have 2.29, 2.5, 2.2. Well, going from least to greatest there, these are all 2, so it's 2 point whatever is the higher number is going to be the bigger number, right? So 2.2 would be the least number there. So E would come next. 2.29 is just slightly above that, so B would come after that. And then C, by default, is the highest number, right? It's not too bad. Once you have it in decimal form, they're pretty easy to compare. Okay, you do the same thing with this last section here. We're going to convert them to decimals. So square root, or cube root, sorry. Cube root of -15.625 is -2.5. -19 over 5 is -3.8. And then -3, 3 divided by 4 is 0.75. And those are already in decimals. Okay. So least number is always my most negative number. So that would be B, right? -3.8 would be the least number. And then -3 would come next. As we get more positive, we're getting closer to 0, right? And then -2.5 is a little bit closer to 0. And then 0.75 is just above 0. And then 1.2 is just a little bit above that. So that would be my ordered numbers. Again, once you have in the decimal form, I mean, if I write those out, -3.8, -2.5, or sorry, -3, then -2.5, then 0.75, then 1.2. Okay, it's pretty easy to compare once you have them written out there. Okay. Last section is identifying if something is rational or irrational. So something that is rational is something that can be made into a fraction. Okay, so this includes fractions, obviously, whole numbers, because you can always put a number over 1, right? Or decimals that stop or repeat. Okay? Irrational numbers are numbers that are decimals that go on forever without any kind of pattern. So that would be like a number that, keeps going and doesn't have any kind of pattern. It's not like 0.6 repeating or 0.12121212. It's just a bunch of numbers that go on forever. Okay, so let's look at some examples. So number 19. Now, this is something that a lot of students will do, is they will take something like number 1 and do 29 divided by 333, and they'll get this decimal. Now, this is a repeating decimal, but they'll see that it goes to the end and they'll think, oh, it's irrational. But the very definition of a rational number is something that is made into a fraction. This starts as a fraction, so this is rational. Okay? Negative 2 is a whole number. I can just do negative 2 over 1, right? So that is also rational. Okay? Cube root of 64. With these cube roots and square roots, we do need to figure out what the actual number is. So you got to find the cube root of 64, which is just 4. 4 is a whole number. That's also rational. Okay? Pi. Pi is the definition of an irrational number, right? The mathematicians will count out pi for ages and ages, and they still haven't found the end of pi. Pi goes on forever without a pattern. So pi is an irrational number. Okay? This number, it's not repeating at all, right? It keeps going on forever. Now, 2, you see 2 a few times. That's not what I mean by repeating. By repeating, I mean it's the same number over and over again. Okay? Or the same 2 numbers or 3 numbers. So, like this is a repeating decimal because it's 0.087, 0.087, 0.087. Just that it's little numbers here and there that are the same. There's only, technically 9 numbers, right? Or 10 numbers, sorry, counting 0, that you can have. So there's obviously going to be some numbers that repeat, but there needs to be a pattern to the repetition for it to be a rational number. So this is irrational. And then the square root of 5, again, plug it in our calculator, and it doesn't give me the decimal, so I have to convert it. 2.236067978. There isn't a pattern there, right? It's just a bunch of numbers. So this is irrational. Okay. So again, rational numbers that can be turned into fractions, and this is probably the one that will confuse you the most. A decimal can be rational. It's just if it stops or repeats, it can be turned into a fraction. But if it doesn't, if it goes on forever, it's irrational. Okay, if you have any questions or concerns, talk to your teachers. We're here to help. We want to help, and I'll see you out there.